Okay, so in this example, we're being asked to simplify radicals with variables. So we'll do a few examples here. Now here is our first example. So notice that we do have a variable. So what I'm going to do here is, first I'm just going to simplify down 54. So we have the square root of 54, and then we'll worry about this variable, okay? So we're going to use prime factorization here. So let's just pick two numbers. When I multiply will give me 54. We can just say 9 and 6. Okay, and then breaking this down further, we get 3 and 3, and then 2 and 3. So I just broke it down into its prime factors. Again, that's prime factorization. Now, since it's a square root, we need two of the same number in order to pull it out, right? So right here, this is a pair, meaning we can pull out a 3. I don't have a pair for 2, and I don't have a pair for 3, so those stay underneath the radical. So essentially you have this, you have 3 square root of 2 times 3, which we know is 3 square root of 6. Okay, so that's the square root of 54. Now we want to work on our variable. Alright, so we have the square root of x cubed. Alright, and it may be useful to understand, if you forgot, what the square root actually is. So for example, if I have the square root of x, that can be written as x to the half. If I have the cube root of x, that can be written as x to the 1/3. Right? Fourth root of x, that can be written as x to the 1/4. Right? And so on. Okay? So what you want to do here is you want to try to make your variable here squared. That way you can pull it out. Okay? So for example, it's going to erase this, just rewriting what we have here. We have the square root of, I can say x squared, right, times x. That is x cubed. But notice I have it squared here, this can come out. Alright, so I pull out an x, and this x stays behind. So my final answer is going to look like this. 3x square root of 6x. This right here is your final simplified answer. Okay? So let's try another example. Okay, so here's our next example, and notice now that we're dealing with the cubed root. So the only difference here, instead of having 2 of the same number in order to pull it out, we now need to have 3 of the same number in order to pull it out. So let's go ahead and just work on 72 first. So I'm going to have the cubed root of 72, and then just using prime factorization, we can use 8 and 9. This gives us 4 and 2. 2 and 2, and 3 and 3. So notice here that I have 3 2's. That means a 2 can come out, but if I look at my 3's, right, I only have 2 of them. So those 3's need to stay underneath the cubed root. So we're going to have the following here. We get 2 cubed root of, and then 3 times 3 is 9. Okay? So there it is. Now we need to work on our variable. So we have the cubed root of x to the 7th. So the goal is to get this to say x cubed. That way we can pull it out. So for example, we can rewrite this the following way. We have the cubed root of x cubed times x cubed times x. So I have an x cubed and an x cubed. Those 2 can come out. This stays underneath, so I now have the following. I have 2 times x, and then I have the cubed root of 9, right? And then this stays underneath x. And then just rewriting this one more time, we get 2x squared, and then we have the cubed root of 9x. Okay, and this is going to be our final answer here. Okay, so let's try one more example. Alright, so here's our last example. So now we have the fourth root of 81, x to the 5th, and y to the 7th. So I'm going to do the same thing here. I'm just going to work on our number first. So we have the fourth root of 81. So again, the only difference here, now we need 4 of the same number in order to pull it out. So breaking this down, we get 9 and 9. This will give us 3 and 3, 3 and 3. So I have it down to its prime factors. Notice how this works out. I have 1, 2, 3, 4 3's, meaning, right, I have enough for 1 to come out. So we can rewrite this the following way. It's just going to be 3. So the fourth root of 81 is 3. Okay? But now we have to take care of our variables. So let's go ahead and take a look at that. So let's work on x to the fifth first. So we have the fourth root of x to the fifth, and we can go ahead and rewrite this. The fourth root of, we can say x to the fourth times x. So here I have it to the fourth power, meaning an x can come out, but one has to stay behind. So we have x, and we have to the fourth root of x. Okay? Let's work on y to the seventh now. Let's erase this. So we have the fourth root of, here we have y to the seventh. Let's go ahead and rewrite this. So the fourth root of, we're going to have y to the fourth times y to the third. Okay? So this can come out, but this needs to stay behind. So we have 3x, remember this comes out, y. Then we have the fourth root of x, and this is staying behind, y to the third. Okay? This here is going to be our final answer. Okay, so that is simplifying radicals with variables. Okay, and that is it.